Okay, today we learn all about antiderivatives. So what we've been finding up to this point are derivatives. The antiderivative basically means we just go backwards. So for derivatives, you take one away. For antiderivatives, you add that one back. So the symbol for antiderivatives, you will see a symbol that looks like this. This represents the indefinite integral and represents the family of all antiderivatives. So when we set up for an antiderivative, we say the integral of f of x dx. So this means we are taking the integral with respect to x. And the result will be another function plus the constant of integration. And the last statement says the way to check if you have the right answer, well, the derivative should equal the inside function. So that's a way to check your work. Once you find the antiderivative, you can take the derivative to see if you've done everything right. Okay, so again, that curvy little symbol is the integral symbol. The function inside is called the integrand, and the symbol dx indicates that we are taking the antiderivative with respect to x. And c is the constant of integration. So c will always be tagged along on there no matter what. So c is always the constant of integration. Okay, now here are the formulas for antiderivatives. The first one is one of the most important ones. It is the power rule for antiderivatives. So this is the power rule. And remember I said for antiderivatives, we add the one back. So if we're given a function x to the n, then the antiderivative is going to be x to the n plus 1 over n plus 1 plus c. So that is the power rule. That's going to be the most popular rule we use today. And then rule 2 says the integral of e to the x dx is, guess what? E to the x plus the constant of integration. How funny, right? The derivative of e to the x is e to the x, and the antiderivative of e to the x is e to the x. Okay. 3, the integral of 1 over x dx will become the natural log of the absolute value of x plus c. So look out for that. If you have 1 over x, then the antiderivative is the natural log of x. Okay, 4 says some constant times a function. So the integral of some function, some constant times a function. Well, what this property allows us to do is take that constant and move it to the outside. That's what we've been able to do with limits. It's what we've been able to do with derivatives. And now it's what we're able to do with antiderivatives. Okay. 5, the integral of f of x plus or minus g of x with respect to x. All this says is, hey, if you have multiple terms inside your integral, then you can split it up into multiple integrals. It becomes the integral of f of x plus or minus the integral of g of x. And then 6, this is an important rule. The integral of some constant with respect to x will just be kx plus c. So if you're ever given a number by itself, then the antiderivative is just kx plus c, of course. So we'll call this the constant rule. Okay, so let's go ahead and try out these integrals. Let's find the antiderivatives using the rules above. Okay, number 1, the integral of 7dx. So this is a number all by itself. So this is going to use the constant rule. So the integral of 7dx is just going to become 7x plus c. That's it. That follows rule number 6 up there. And of course, how do you check your work? Well, take the derivative. What's the derivative of 7x?
7.
7. Look at that. And what's the derivative of any constant?
It goes away. 0.
0. Good. There you go. That's how you check your work. That's done. Okay. 2. The integral of 8x dx. Okay. So what we're going to do here is separate the 8. We're going to move that 8 to the outside. So I'm going to get 8 times the integral of x dx. And now we are going to use the power rule on this integral. So that's x to the first. So this becomes 8 times, and the way the power rule works is you're going to have x to the 1 plus 1 over the same exact thing, 1 plus 1. So we have just used the power rule. Okay. And now cleanup, you get 8 times x squared over 2. Simplify. 8 times x squared over 2 becomes 4x squared. And do not forget the tack on c. There it is. And again, check your work. What's the derivative of 4x squared?
8x.
Right there. Beautiful. All right, any questions so far?
Good.
Good. All right, 3, same exact thing as the above. The integral of 9x squared. We are going to separate the 9. We'll move it to the outside of the integral. You get 9x squared dx, and we're going to power rule again. So 9 times x to the 2 plus 1 over 2 plus 1. So we add that one back, and we get 9 times x cubed over 3. Simplify, and 9 divided by 3 gives me 3x cubed. Do not forget the c. And again, check your work. The derivative of 3x cubed, 9x squared. All right. 4, power rule again. So x to the 5th, you're going to get x to the 5 plus 1 over 5 plus 1. This gives me x to the 6th over 6th over 6 plus c. Hey, that's done. That one wasn't bad at all. So you see here, power rule is your best friend. Oops. Okay. Any questions on that first page?
Nope.
All good, all good. Okay. Keep going. All the examples. All right. 5. The integral of x to the negative 3 dx. This again, we'll use power rule. So you'll get x to the negative 3 plus 1 over negative 3 plus 1. This will give you x to the negative 2 over negative 2. Okay, So I don't know if it will take this as an answer. So we can always rewrite it using our exponential properties. And this will become 1 over negative 2x squared. So that x to the negative 2 just flips below. That works, but I hate negatives in my denominator. So I just move it to the top and make it negative 1 over 2x squared plus c. All right. That. That's good. That's good. All right. Do it again. Number 6. All right. So just like the others, take that 10, move it to the outside. 10 times the integral of x to the 3/2 dx. And this, once again, we'll use power rule. So you'll get 10, and put brackets there, to the x times x to the 3/2 plus 1 over 3/2 plus 1. A little bit of fraction work. 3/2 plus 1, you make it 1 over 1 and get a common denominator of 2. So this will give you 3/2 plus 2/2, which gives me 5/2. So that's what we're going to have next. X to the 5/2 over 5/2. Okay. And of course, we can't leave it like that. So we are going to, since you have a fraction in your denominator, you must multiply by the reciprocal. Or what's easier to see here is all we're going to do is flip this. So just flip this fraction, and the 2 will go to the numerator, and the 5 will stay in the denominator. So we get 10 times 2x to the 5/2 over 5. And now we can multiply the 10 in there, and you'll get 20x to the 5/2 over 5, but 20 over 5 reduces to 4. So our final answer is 4x to the 5/2 plus c. Any questions on that one with all the fraction work? Breathe it in. Okay. Keep moving. 7. 3 over z. So we're going to rewrite this. I'm going to move the 3 to the outside. So there's going to be 3 times the integral of 1 over z dz. Now this is going to use the property on the first page, where the integral of 1 over x dx is the natural log of the absolute value of x plus c. So we're using this exact formula from the first page. Our only difference is the variable is z. So this actually works out really nicely. You'll get 3 times the natural log of the absolute value of z plus c. That's it. Nothing to it. Okay. Everybody good? Everybody good? Still going. 8. 16, e to the u. Again, move the 16 to the outside. 16 times the integral of e to the u du. And this will use the property on the first page as well. The integral of e to the x dx is e to the x plus c. So for this one, again, the only difference is the variable is u. So this antiderivative will become 16 e to the u plus c. That's it. Okay. 9. All right, now we got a little bit more work to do here. You have the integral of 5x times 1 minus x. So we actually have to fix this algebraically before we do anything. What we're going to do first is take that 5 and distribute it into the 1 minus x. So you're going to get the integral of 5x minus 5x squared dx. So I just distribute it to both terms. Okay, and now by the properties on the first page, I can actually split this into 2 integrals. So this will become the integral of 5x dx minus the integral of 5x squared dx. So we just took it and split it into 2 integrals. Okay. Well, now all we have to do is use power rule on both of these integrals to find the antiderivative. So for the first one, you're going to get 5 times x to the 1 plus 1 over 1 plus 1 minus 5 times x to the 2 plus 1 over 2 plus 1. Here, you'll get 5 times x squared over 2 minus 5 times x cubed over 3. And my final answer is going to be 5/2 x squared minus 5/3 x cubed plus c. There it is. All right. 10. Integral of du over the square root of u. So we have some fixing to do before we find the antiderivative. So first thing we're going to do, what was that? In green. All right, good. So the first thing we're going to do is rewrite this as the integral of du over u to the 1/2. And then the next thing we're going to do is flip the denominator to the numerator using our negative exponent rule. So we'll get the integral of u to the negative 1/2 du. Okay. So we have algebraically fixed it, which means we are now ready to find the antiderivative. And this again is going to use power rule. You'll get u to the negative 1/2 plus 1 over negative 1/2 plus 1. So u to the negative 1/2 plus 1 over negative 1/2 plus 1. Okay. And for your fraction math, well, that's negative 50 cents plus $1. So that just leaves you with 50 cents over 50 cents. And we can't have that fraction in the denominator, so we will flip, which means the 2 goes to the numerator, the 1 stays in the denominator. So our final answer is 2u to the 1/2 plus c. Or 2 square root of u. All right, how are we doing?
Doing all right.
All right. Okay. 11. dx, the integral of dx over 4x cubed. So again, let's go ahead and fix this up. I'm going to take the 1/4 out, and you'll get 1/4 times the integral of dx over x cubed. And then we'll use the negative exponent rule and flip the x cubed up. You'll get 1/4 times the integral of x to the negative 3 dx. And then, once again, the most popular rule, we do power rule. So that 1/4 stays outside, and I use brackets just because I think they're neater. You can put parentheses if you want. And by power rule, negative 3 plus 1 over negative 3 plus 1. Here, you'll get 1/4 times x to the negative 2 over negative 2. Okay. And now clean up. If I multiply that straight across, you get x to the negative 2 over negative 8. Now I hate negatives in my denominator, and we probably don't need that negative exponent in the numerator. So we can rewrite it as negative 1 over 8x squared plus c. All right. 12. We have the integral of 4 plus u over u with respect to u. So we don't know how to take an antiderivative in this form. So again, we can clean this up algebraically. So what we see is that there are two terms in the numerator over the same denominator, which means I can split this into two fractions. 4 over u plus u over u with respect to u. So all I did was take the fraction and split it into two fractions. And now we have to reduce. So this will be the integral of 4 over u plus u over u is just 1. Okay. We are now ready to find the antiderivative. So the first thing I'm going to do is split this into two integrals. I'll get the integral of 4 over u du plus the integral of 1 du. Okay, one more step before we continue. I'm going to pull that 4 out, and you'll get 4 times the integral of 1 over u du plus the integral of 1 du. Now we will use the properties on the first page. This one uses the natural log property. So this will become 4 times the natural log of the absolute value of u plus the integral of 1 du uses the constant property. So this becomes 4 natural log u plus c. There it is. All the rewriting just to get there. So again, purely algebraic still. All right. Okay, 13. Integral of 5e to the z plus 4 dz. So don't have to rewrite anything algebraically this time, but I can split this into two integrals. I can make this the integral of 5e to the z dz plus the integral of 4 dz. Okay. And now one more rewrite. I'll pull that 5 out. 5 times the integral of e to the z dz plus the integral of 4 dz. And now we're going to use the formula for e to the x that's on the first page. And the antiderivative of e to the z is, guess what? E to the z. Plus the antiderivative of 4. 4 is a constant. So you're going to get 4z plus c. There it is. Cool. All right, 14. More practice. So Let's go ahead and split this into two integrals, and maybe we can skip steps this time. So the integral of 3x squared, I'm going to rewrite as 3 times the integral of x squared dx. And then the integral of -2 over x squared, I'm going to have minus 2 times the integral. And that x squared needs to flip up. So it's going to be -2 times the integral of x to the -2 dx. There we go. So I've rewrote it as two integrals, and all I've done is take the coefficients out. And then for that fraction, I just took that x to the -2 and flipped it up. Okay, which means we have power rule on both. So you'll get 3 times x to the 2 plus 1 over 2 plus 1 minus 2 times x to the -2 plus 1 over -2 plus 1. We use power rule. We clean up. 3 times x cubed over 3 minus 2 times x to the -1 over -1. Here my 3's will cancel. So 3x cubed times 3, you just get x cubed. And then this negative over that negative will become positive 2x to the -1 plus c. All right, not bad. Okay. All right. Of course, more. So 15, you have the integral of 2x to the 4th minus x over x cubed dx. Again, we don't know how to take the integral in this form, so we have to fix it algebraically. So just like the others, or one of the last ones we worked, there's two terms over the same denominator. This means that we can split it into two fractions. So you'll get the integral of 2x to the 4th over x cubed minus x over x cubed dx. So I split it into two fractions, and now we have to reduce. So we'll get the integral, and 2x to the 4th over x cubed will just become 2x. And then negative x over x cubed becomes -1 over x squared. All right. And now let's split it into two integrals. And for the first one, for 2x, I'm going to take that 2 out, and you'll have 2 times the integral of x dx minus, and then for the 1 over x squared, we're just going to flip it to the numerator. So you're going to get the integral of x to the -2 dx. And now we will power rule on both of these. So 2 times, so that's x to the first, and you'll get x to the 1 plus 1 over 1 plus 1 minus, and then I'll put a bracket there, x to the -2 plus 1 over -2 plus 1. Okay. Cleanup. 2 times x squared over 2 minus x to the -1 over -1. On the first one, my 2's cancel. So you'll get x squared. And then again, negative over negative makes positive x to the -1 plus c. Oh, yeah. All right. Still hanging in there?
Yep.
Trying.
All right. All the algebra, right?
Yeah, pretty much.
All right. Okay. 16. Another one just like that one. So you have the integral of x to the 5th minus 2x over x to the 4th. So again, two terms in the numerator over the same denominator, split it into two fractions. So we get the integral of x to the 5th over x to the 4th minus 2x over x to the 4th dx. So just split it into two fractions. And now we reduce. The integral of, and x to the 5th over x to the 4th is just x. Minus 2x over x to the 4th becomes 2 over x cubed. Okay. So now we split it into two integrals since all the reducing is done. And I get the integral of x dx minus, and I'm going to take that 2 out, 2 times the integral, and I'm going to flip the x cubed up to make it x to the -3 dx. Okay. And all we have left to do is power rule on both of these. First one, x to the 1 plus 1 over 1 plus 1 minus 2 times the second one, x to the -3 plus 1 over -3 plus 1. Here we get x squared over 2 minus 2 times x to the -2 over -2. And my final answer is 1/2 x squared. -2 over -2 will cancel to +1, and you'll get positive x to the -2 plus c. Okay, there we go. We got one more and then word problems. Cool. All right. 17, just like the two above it. Two terms in the numerator over the same denominator. So split it into two fractions. So here we get the integral of x squared e to the x over x squared, and I keep those together because they're connected by multiplication, minus 2x over x squared. Dx. Now reduce, and your x squareds will cancel, and that will leave you, so for this one, your x squareds cancel, and you'll be left with the integral of e to the x minus 2x over x squared becomes 2 over x dx. Okay, there. Everything's been reduced. Now split it into two integrals. The integral of e to the x dx minus, I'm going to take that 2 out and multiply by the integral of 1 over x. So you notice how we never ever flip an x by itself. We never ever do that. If it's x squared or x cubed or x to any other power, you will always flip it, but never ever flip 1 over x. I'll show you why in a second. Okay. All right, everything's separated. We're ready to go. Lucky for us, the antiderivative of e to the x is e to the x minus 2, and the antiderivative of 1 over x is the natural log of the absolute value of x. And don't forget the c. Here's the caution. So integral of 1 over x dx, if you made it into the integral of x to the negative 1 dx, well, we're going to run into issues, because if you use the power rule on this, you'll get x to the negative 1 plus 1 over negative 1 plus 1, which gives me x to the 0th over 0. And x to the 0th, anything to the 0th is 1, and the denominator is 0. Can you ever have 0 in your denominator?
No.
No. So do not flip 1 over x. Okay. Guess we should say that that becomes undefined. Okay. Or we just say that that integral doesn't exist. So never flip 1 over x. You can flip everything else, just do not flip 1 over x. Okay. Any questions on that page? Integrals are a good time. Okay. Now, word problems. The marginal average cost of producing X sports watches is given by C bar prime of X equal to negative 1,000 over X squared. And they're giving us that C bar of 100 is 25. C bar of X is the average cost in dollars. Find the average cost function and the cost function. and find out what are the fixed costs. Oh boy. So here's a little 1324 review. Cost function is C of X. And remember, the average cost function is C of X over X. And then what we learned during this semester is that you can have an marginal average cost function. And remember, the word marginal just means derivative. So C bar prime of X means you have the derivative of the average cost function. So our goal is to use the antiderivative today to go from C bar prime back to C bar of X, because it says, what is the average cost function? Find the average cost function. So that's what we're going to do first. Find the average cost function. Okay, this is going to be, we'll call this A. Find average cost. So in order to do that, we set up an integral. We say the integral of C bar prime of X dx. And now plug in C bar prime, in which they gave us that above. C bar prime is negative 1,000 over X squared. So C bar prime is negative 1,000 over X squared. Now let's find the antiderivative. So in order to do that, take out the negative 1,000, and then you'll have it multiplied. We're going to flip the X squared. So it's going to be the integral of X to the negative 2 dx. And now power rule. I'll do it on the same line. Sure. Negative 1,000 times X to the negative 2 plus 1 over negative 2 plus 1. Simplify. Negative 1,000 times X to the negative 1 over negative 1. And again, negative over negative becomes positive. So we end up with 1,000 X to the negative 1 plus C. Here is our average cost function. Okay, but it's not done, because if we want the complete average cost function, we are now going to have to solve for C. So they give us a nice little clue on how to solve for C. That's the second clue that was given in the problem. It says C bar prime of 100 is equal to 25. So we're going to use that clue next. Okay. So we're going to say B. Find C. So we're using that clue. C bar of 100 is equal to 25, right? Yep. And that means we are going to use this in the new average cost function. So that is C bar of X is equal to 1,000 X to the negative 1 plus C. So what we're going to do is plug 100 in for X. So we're going to have C bar prime, just C bar of 100 equal to 1,000 times 100 to the negative 1 plus C. Okay, but the part of the clue says when C bar of when you have C bar of 100, that equals what number?
25.
25. So this becomes 25 equal to, and 1,000 times 100, I think that's just 10, right? 1,000 times 100 to the -1, that gives you 10 plus C. Therefore, C is 15. And what this all leads to is the actual average cost function. So C bar of X is now 1,000x to the -1 plus 15. There's the average cost function. Okay. So now it says find the cost function. So this will only involve algebra, no calculus involved. So our goal now is to go from the average cost function back to the cost function. So remember, to make an average cost function, it's the cost function over X. So that's what we have to look at here. So C, I'll say find the cost function, C of X. Okay. So what we're given is C bar of X is equal to 1,000x to the -1 plus 15. Well, I can rewrite this as 1,000 over X plus 15. And all I have to do is put these two terms together by getting a common denominator. So if I put 15 over 1, I just multiply by my common denominator of what?
1.
Well, X over X. Because you want them to have the same denominator. So I multiply that by X. So this becomes 1,000 plus 15x over the same denominator of X. And now you have C bar of X, now you have C of X over X, which is your average, which is your cost function, right? So the numerator ends up being your cost function, because that's how the average cost works. C bar of X is C of X over X. So our cost function is just C of X equals 1,000 plus 15x. There it is. All right. Last piece, it says, what are the fixed costs? So remember, on a function, on a cost function, there's fixed cost and variable cost. Well, 1,000 is your fixed cost and 15 is your variable cost. Ooh, man. All right. Any questions on that one?
Nope, that one seemed almost easier, actually.
All right. Just a lot of going backwards, right?
Yeah.
Okay. Do we have one more? I think we have one more. All right. Last one, I think. Yeah. All right. So 3. Monthly sales of an SUV model are expected to increase at the rate of S prime of t equals negative 24 t to the 1/3 SUVs per month, where t is the time in months and S of t is the number of SUVs sold each month. The company plans to stop manufacturing this model when monthly sales reach 300 SUVs. If monthly sales now at 0 months are 1,200 SUVs, find S of t. How long will the company continue to manufacture this model? Ooh la la. So we got some stuff to find out on here. So first off, let's go ahead and answer the first question. Find S of t. They're giving us S prime, which means to find S, we need to do the antiderivative. So again, call this A. Find S of t. So set up our integral. The integral of S prime of t dt, and now plug in S prime of t. So you get the integral of negative 24 t to the 1/3 dt. And now let's find the antiderivative. So I'm going to move that 24 out. Negative 24 times the integral of t to the 1/3 dt. And now we'll use power rule. So we get negative 24 times t to the 1/3 plus 1 over 1/3 plus 1, and 1/3 plus 1 becomes t to the 4/3 over 4/3. And once again, can't have that fraction in the denominator, so you flip it. The 3 goes to the numerator, the 4 stays in the denominator. So we end up with negative 24 times 3t to the 4/3 over 4. Okay. And now we know that 24 over 4 is 6. So that becomes a 1. That becomes a 6. And then you get negative 6 times 3, which will give me negative 18 t to the 4/3 plus c. Here's S of t. Well, there's almost S of t. Okay. So then for this one, in order to find out what C is, all right, they're giving us a clue. They're telling us that when time is 0, there are 1,200 SUVs. Okay. And that's still negative, right? Yep, negative, and then 4/3. Okay, good. So here we're going to find C now. And we're going to use one of the clues they're giving us. They're saying that when time is 0, there are 1,200 SUVs. So what that means is that at S of 0, we have 1200. Okay. Oh, this is going to be really easy. So use that clue. And first off, let me rewrite our S of t, negative 18 t to the 4/3 plus c. This means you'll plug in 0 for t, and you'll get negative 18 times 0 to the 4/3 plus c. But no matter what, that becomes 0. And the left side becomes 1200. So you'll get 1200 equals C. So the actual equation is S of t equals negative 18 t to the 4/3 plus 1200. There's the real S of t. Okay. And we have one final thing to answer. It says, how long will the company continue to manufacture this model? So we read the problem again. It says, the company plans to stop manufacturing this model when monthly sales reach 300 SUVs. So that's our next clue. We're going to solve for time here. So for C, we're going to say find time when S of t reaches 300. So all we're going to do with that is take 300 and plug it in for S of t, not t, S of t. So you're going to get 300 equals negative 18 t to the 4/3 plus 1200. And we're going to solve for t. Move that 1200 to the left, and we're going to get negative 900 equals negative 18 t to the 4/3. And then divide by 18. Hey, that's a nice number. You get 50 equals t to the 4/3. Okay. And now to solve for t, all you're going to do is raise both sides. Yeah, I'll write this. You're going to raise both sides to the opposite exponent, or I should say the reciprocal exponent. So if this exponent is 4/3, to get rid of it, you're going to raise everything to the 3/4. And I'll show you how that works. So if you raise everything to the opposite or the reciprocal exponent, well, remember, power to a power is multiplication. So 4/3 times 3/4 will cancel. And this will become 50 to the 3/4 equals t. Or in your calculator, you can type 50 raised to the 0.75. And 50 raised to the 0.75, we get 18.8 months. And my math lab's probably going to make you round up. Hopefully, if not, they'll make you round down. So most likely this is just going to say 19 months. If it makes you round down, then it's 18 months. But there you go. Last one for the day. For the week. My goodness.